Welcome to the lecture series on object oriented analysis and design. The approach which we have been taking right now in this set of lectures is re-engineering. Re-engineering allows us to focus on the value. What is that kind of a value addition which we can give to the software development effort? Re-engineering was proving to be a very effective idea. It was re-engineering that made us pick what comprises an infrastructure. Today in the service oriented architectures model, we talked about infrastructure as a service. What is infrastructure? What is software? What is a platform? All these three were nicely getting structured, segregated in the way we have been talking about in the process of re-engineering. That is a single biggest movement which we can think of in the way we are looking at the entire software development effort. Otherwise, overall software engineering is a completely different discipline. It is engineering, but not something that is comparable to other hardware engineering disciplines. In the process of just 50 years of rigorous work, we have shown something like a surprisingly high 36% success rate. Even though it is very dismal, nearly 64% is not into the success zone, 64% of the projects we can't assure much. Even today we keep telling the same thing, that at least 25% of the work will have to happen in the deployment site. So, what we have done overall outside of those basic principles and the way we brought about the concepts, practitioners approach, quality imperative, only quality speaks, metrics, quality frameworks, systems, project management ideas, all of them put together, we started observing very carefully to segregate them as platform, infrastructure and software. So, what came out of that re-engineering effort is a clear way of defining what are those infrastructural elements. Then we talk about the platform, we talk about the service. This was proving to be a very good idea, and once we started talking about the infrastructure, we started telling that what will be the components, already existing things can be reused, the componentables, they are searchable, they are quantifiable, they are usable, they are always supportable. Anything, it can be a code segment, it can be a prefabricated thing, it can be a component, it can be whatever it is. So, we talk about a way of working forward. Many times it is the case. These were very well known. For example, I had an MTech project student who was given a task, his outside project, he was given a task of looking at a card that was done with lot of interest. Then the business dynamics changed. Nobody was working on that card for some time. It was a good live activity in that organization. They made the card, they did something, and then they said no, the business is not conducive for this kind of a card to be sold. They put it aside, whatever be the reasons. Quite some time later, they were thinking of a possible functionality related to that card. There is a process asset library, the project asset library. Somebody was browsing through those records, felt that some earlier work has been done with the internal work, nobody knew what it was, and this can be brought back. Let us see what best can happen. The ideas are there, maybe with some suggestions here and there we can come up with the business idea. So, only the card is available. In the library, one or two names who were associated with that card development was available. So, a good MTech project happens in reconstructing what could have happened in this card design, cull out various documents, various internal reports. We do not know where other reports are there. The project asset library of that olden days was just a few indicators and pointers. It was a very good exercise. We called it, first we started talking about reverse engineering. Then we said that we identified some constraints, forward engineering. Eventually, we talked about re-engineering with some guesses, with some kind of a testing capability based on certain input, certain data which is available in various forms, various places, we were able to reconstruct about 30 to 40% of what exactly was that card was expected to do verifiably and provably. Now, that we thought was the core functionality. Our role ends there. They won't use us any beyond that. As an MTech student, I am an external. We simply discussed, deliberated, presented, and then we said this is what it is. According to us, this remains the core functionality. But then they were quite contented, and then they said this is a good project, and the MTech student was absorbed. After that, we won't come into picture. It went through. Later on, when he met me, he was mentioning that it was a very good project, we could carry forward. They did something else. So, the idea of reverse engineering is very, very valuable in a limited scale. This is a practical case. Most industries have these concerns. So, it is not such a serious value add because nobody was interested. After some time, it was just lying there. It was simply there, and the business dynamics are very, very clear. When they wanted to pick up, if we can get this kind of a value add, then it will be great. We could showcase that all those are necessary. A component makes its services available through interfaces, and interfaces are of certain types of categories. What are component packages? Component packages must have component, API documentation. Component packages should have technical documentation, user cases, component packages extras, installer, middleware packaging, costs and advantages of making packages. The typos in that: component packages must have, component packages should have. So, there are certain technical demands. What makes a package is a question. Java is one language that has perfected the way in which packages are made and made available. If we study the way Java programming was happening, the Java as a language specification was happening, packages are outstandingly done in Java with a simple sandbox security model and a virtual machine. It is a great exponentiation of the idea of packaged pieces of software. Originally, we were talking about packaged software packages were third party. Now, this is component packages. If you want, you use it, otherwise you do not. In the third party packages, it was not an option. Costs and advantages of making packages, component description, technology is developed in using that compatibility, development methods, functional specification, interface specification, use case, OS platform compatibility, extensibility, testing specification, known deficiencies, version data, supportability data, evaluation, critique, comment by others. Do we want to do all this over and over again is a very big question mark. If so much effort has gone in finding out what are the common objects which can become good components, why do we want to reinvent the wheel? So, this is something which I am in need of. You please flash all over the net. You will find some component which fits the bill. Please use the service, provided the service level agreements, then the design by contract are taken care very well. So, technology developed in technology compatibility, development methods, functional specification, interface specification, use cases, use scenarios, OS platform compatibility, extensibility, testing specification and performance data, known deficiencies, version data, supportability data, evaluation, critique, comment by other users. So, these are certain simple descriptors which we have been talking about: component and component description. So much of effort goes, description itself is so much. Please think of the component, how the packaging is made. That process of identifying components and packages is by far the best in the Java programming language. You can define packages and link them with a simple idea. Types of component platforms: the early implementations, Microsoft's component object model platform using C++, C, VB, very cumbersome, it went out of fashion, and very soon it was distributed, saying that they are all over the world, such things can be anywhere. That became DCOM, that also did not really fly. Tool based platforms: Delphi, Visual Studio, Office, Excel, managed platforms, .NET, .NET XML, declarative approach, managed software encourages aspect oriented programming, vendors, J2EE, J2Beans, Java Beans, all these things have been various attempts in talking about component, and anything that is based on component, it can be a package, it can be a platform. So, as I said again, it is the idea, the core idea called re-engineering that made us segregate the entire effort as some things related to platform, some things related to infrastructure, something related to the software as such. So, 2/3 of it, the platform and infrastructure, are nicely manageable in object oriented programming using this paradigm. It can be synonymous with a software engineering technique based on OOAD, that is object oriented software engineering. It can be synonymous, OOAD can be simply synonymous with UML, and UML may be completely compatible with very many things that we have been talking about. However, the core concerns are still addressed using what is called the language paradigm. Talked about vendors. So, what is the definition which we are talking about? A software component is a unit of composition with contractually specified interfaces and explicit context dependencies only. Not all of the context is necessary for us. Relevant, pertinent context. From the point when we were doing software engineering, we were talking context free. The moment we talk about languages, paradigms which are leading to languages, we still talk about why is that language context free. The grammar which is underlying that language is context free grammar. So, therefore, how do we bring the context? How do we bring the adequate context into it? Therefore, we started talking about other ideas associated with object oriented languages. Today, it is a full fledged exercise. You call it re-engineering, you call it unified modeling language. We do understand that 2/3 of the exercise simply gets segregated into what we might have already done, forgotten, what is existing elsewhere can be reused, simply talk about vendors who will supply that. So, 2/3 of the exercise is automatically visible. We have to see how this 2/3 of the exercise fits into the deployment, the context. Only the relevant context is necessary, and that is exactly the strength of this approach. A software component can be deployed independently and is subject to composition by third parties. We can have third party exercise. European Conference on Object Oriented Programming, 1996 it was, when we got the very good definition of that exercise on what makes a software component. This is my choice definition, 1996 European Conference on Object Oriented Programming. So, they identified what is a component. So, nearly 25 years, and we do not have that many components to talk about. Only when there was a vertical we were able to talk about reuse, but the idea is good. Encapsulation cannot be partially deployed, must have clear specification of what it requires as well as what it provides, must have well defined interfaces. And what is the specification going to be? It provides interfaces, the services a component can offer to a client. It requires interfaces, the services required by a component to help it deliver its promises. Context of use, it is the world the component lives in, that is the context. Where should the component become live is the question. How to put the components together, how to combine distributed heterogeneous components, how do you specify the interfaces, all big questions. Already we had difficulty in terms of identifying what is an object, how to identify an object. Till today the identity of an object is quite slippery, and then modeling the relationships, all these are stiff challenges, and without taking recourse to the kind of nice tools based on unified modeling language, most of the time we think that we will not be able to handle the complexity. Programming is like that. We have reached a point where we tell that for the business considerations we may have to keep using the tools. Verification, validation, all these things are dependent on how well we did the composition. So, we have some more definitions to come. A component must have clearly specified interfaces. A component is encapsulated and its dependencies are designed in such a way that it can be treated as independently as possible. These are the lessons we learnt in the overall domain of software reuse. For a component to be developed independently, a clear distinction from its environment and other components is required. The implementation must be encapsulated in the component and is not directly reachable from the environment. Software components over the air, it is called SCOTA, very useful in mobile software management. I mentioned in the passing that once again we take recourse not to what is called a unified modeling language, and therefore, the tools, everything about OOAD is synonymous to that. We have a way of looking at it. Software components over the air, SCOTA, is a simple model for mobile software management. We can use it in some language. So, it is a good picture where mobility is the in thing, all mobile things connecting consumers and computing all appear a common interacting methodology, all of them are interacting. There is no special reason to think that they were all disconnected in the first place, all of them are together. Thin clients, variety, heterogeneity, everything is there. All that we are talking about is a TCP IP that connects to so many other devices. So, we started talking about SCOTA. SCOTA operates in this kind of a layering, of which component based middleware is absolutely necessary. And what is it that happens in this? CORBA, Common Object Request Broker Architecture. One good example is what I said, mobile application development. There are sensor nodes, routing node, gateway node, there are so many other operating systems. We have talked about hardware abstraction, cross platform components, middleware API, services and applications and applications. The applications in the mobile world are happening at a frantic pace, very quick pace. So, the component based middleware is giving us phenomenal stability. The hardware has matured fast enough, plenty. The consumer market is obvious. Today each one has a minimum 2 mobiles. Some 10 years back it was a statistic saying that virtually everyone in an organization is having a mobile. Today they have 2 mobiles. Why? God only knows. We can purchase it, we can use it. So, that is how it is. Mobile software development. Mobile software developers must deliver systems faster and at a lower cost while improving reliability and performance. With content being the main selling point, developers cannot continue to develop one size fits all solutions. Tailorability is essential. All pieces of mobile applications are not acceptable to everybody in their entirety how they were made. So, I should be able to break up that mobile application into small services, which is where software as a service comes. I use only that aspect of the application that is absolutely relevant for me. They are memory hungry. The moment we start allowing apps to download, memory is getting consumed very fast. It has to happen in my machine, and we keep telling that for security reasons most of the work must happen on the edge, that is on the device which wants to do computing. Differences between handsets, operator specific requirements. One of these lectures I was talking about software development kits, SDKs. I have worked on what are called mobile brand simulators. We do not have to have the physical equipment. The mobile is there, it is a software simulator, it behaves exactly like the hardware. So, we used to have all these simple debates whether we can make physical calls from software. Things have changed. We have software defined networking, we have had software interfaces to the telephones. TIP, telephone interface program, was there in the Unix way back in 1971. It is not new, it is not at all new. So, we have talked about a mobile brand, and then we started talking about it. It is a challenge, it is very much a challenge to talk about having a component based architecture that fits the bill for everything, including verification and validation. Convenience, it boosts productivity, communicate with others anywhere, access to electronic information, they are quite expensive, battery life is limited, small screen display, slow internet speed, all these things are very important. Different types of mobile devices, pagers, cellular phones, portable media players, laptop computers. So, what is the essence of this? The essence of this is components are here to stay. We learnt how to define the interfaces, package them, everything is there. How to put together the necessary components to build a better application or make different components work together to do a better job. That is the challenge which OMG had. What they defined is common object request broker architecture. The needs of distributed computing arise in 1980s, the central characteristic of which are distributed applications that run on a network of machines, the integration of legacy applications into new systems, the use of different programming languages to write new components or to wrap legacy codes. I have mentioned about it. Service oriented architectures, once they hit a summit, a plateau, we go ahead and then take recourse to object oriented to see if it can offer better solutions. Most of the times when I teach CORBA, it is preceded with a good lecture or two on remote procedure calls, which are the natural success stories in distributed systems. We need to understand that different procedures are operating on different machines completely unconnected. This procedure can call the remote procedure as though it is operating on this machine, but it only sends the parameters, gets back the outcome results. That is all it should be. Remote procedure call and understanding an RPC is very essential to noting that in theory the components or the packages or the functions can be anywhere. By simply exchanging messages, they can orchestrate what they can do together and make it happen. And how much of automation can happen in this exercise, that we will see as we progress. It is a challenge that we need to have an integration of RPCs and object oriented concepts. It gives rise to the notions of distributed components and interface based programming. Clients program to an interface where different implementations of the interface components are possible. Notions like inheritance, delegation, dynamic binding are kept in CORBA. CORBA brings to us a uniformity to a disparate and a varied world of computing. We all talk the same language, that is good enough. We know what we are talking about, we talk the same language, implementation right to the core, right to the deployment, everything is seamless once you tell that we are using CORBA. Interoperability among largely distinct distributed and legacy programs, fostering the development of open architectures, designs that are more easily evolvable and maintainable. The success of lifeline of software is its evolution. So, we are now talking about evolvable complex systems. We are not talking about things that are used and thrown away. We still want to go back to that evolutionary way in which we build things. Overview of CORBA model, framework and core concepts. A CORBA component is an object. Whatever is internal to it is not something that I need to be concerned about, it is an object. A CORBA interface is specified in CORBA ideal interface definition language. A CORBA class implements one or more CORBA interfaces. CORBA is a programming language neutral idea. The execution of a CORBA component is location transparent. That means it can be located anywhere, I can execute it and bring back. Now, what else do we need? We got back to the objects, we got back to the way in which we interface with components, we have gotten back to language neutrality and location transparency. This is the way in which we specify that components can be anywhere. The distributed objects are partitioned into sets. All objects in a set belong to the same process. Each set is identified as a pair. It is the set P2 is on machine M2. The set P7 is on a machine M2, the set P1 is on a machine M1. So, we talk about processes, process IDs, and then we can go ahead specifying what is it that we want to do about it. These are essential CORBA concepts. We talked about the way it goes into the IDs and names of objects. All CORBA objects have globally unique identifiers called interoperable object references, which are machine generated and not intended for human use. A named object has a well known, unique, human friendly name that clients use to access it. A server process advertises one or more named objects. Client processes have no named objects. So, what are the objects that can be used remotely is known to the server. So, it can be however large it is, interoperable object references, they are unified IDs. Access to remote objects, clients access remote objects via references. Lightweight objects that have the same interface as remote objects, except their task is to forward all methods invocations to the server for remote object execution. References can be exchanged among processes, but the location of the remote objects remain unchanged. So, we can talk about various combinations and permutations of which object on which machine talks to which other object, how many are named objects. This is a sample, a simple snapshot which I could draw, just a few named objects, just a few unnamed objects, a few reference objects, you can use them. Once you know the objects, all that you need is an ideal interface definition language. Which objects are available, the server has it, keeps track of it, it floats, it keeps tapping the network. Once a request comes for an object, it is served, service is done. Runs in every CORBA process responsible for communicating with other orbs, that is an object request broker. There are any number of orbs. CORBA is special because it comes from object management group, it aligns well with UML, host of tools are available, it is synonymous with OOAD and therefore, the object oriented software engineering. As I said, there are other technologies based on service oriented architectures, namely the cloud computing and the way in which we are talking about web services, but it is still what we say the stability which object oriented provides, that is sought after, particularly if it is more than a service, it is a functionality. We prefer what is called an object oriented and a CORBA based implementation. What an orb does? Locate the object to which the message is to be sent. If the object is at another process, pass the message to the ORB of that process. If the object is within the same process as the ORB ensures the object is ready to receive the request and pass the parameters to the object. Interface definition language is the basis of CORBA interface centric programming. How these two objects interact is well known, the handshaking signals kind of a thing, the interchange where it facilitates parameters to go into a component, results to come out correctly, the message is given correctly and then the outcome is also given correctly. Language specific compilers will translate ideal specifications into languages, it can be just a package. Suppose the server is written in language L1 and the client is written in L2. Define the interface I of server object by CORBA ideal, it is language neutral, everything talks, it does not matter which language it was originally written. It has phenomenally helped us to understand different pieces of code segments which will come together and work. So, it is language neutral, it is platform neutral, the highest degree of interoperability, the highest degree of commonality is very clearly seen if you use CORBA and IDL. Thank you, we will meet in the next lecture.